HS Tech channel. Hello folks, welcome to the HS Tech channel. In this video, we're going to have a basic overview of how to use and operate VSE, IBM's legendary operating system that is probably the winning candidate for the most user-hostile, hard-to-use operating system ever made. This is, bar none, the most confusing OS you will probably ever use. It makes VMS look like the pinnacle of easy to use, probably because it is. So let's go ahead and connect to the system here. And we are currently looking at the VSE sign-on screen. Now this is an older version. This version is from about 1999 or so. This is the final version of VSE ESA, but it's basically the exact same thing nowadays. The OS pretty much has not changed in about 30 years. So we're going to go ahead and log in as the sysadmin user. We're going to add a user account to the system that we can play around on. So the admin user is sysa. And in this case, I got the password set to the exact same thing. Okay, well, what in the world are we looking at here? Well, this is something called ICCF, and it's basically a CICS-powered, dialogue-driven system. If you're from the ZOS world, you'll probably know what CICS is, the infamous Customer Information Control System, Transaction Processing System. This is basically just a dialogue system that wraps around that. It's pretty much, I would say it's in the same design choice as OS 400, or IBM I, or i5 OS, whatever it's called this week. So we're going to go ahead and head over to resource definition. We're going to start fumbling through the menus until we can add ourselves a user. So we'll go to resource definition, user interface tailoring, and let's just explore what our options here. So we can maintain the user profiles. Well, there's all the users on the system. Unfortunately, there's only one page, so I can't really do much scrolling. You can see that we have this special user, we have a CICS user that really isn't good for anything. This right here is the user that the CICS region runs on. ForSec is basically the backdoor user. If you get locked out, there you go. Oper is the special operator user. Post, this is used when you install the system. Prod CICS, this CICS instance does not exist on here. Prog, this is just a generic programmer user. P390, this is another generic user account that is considered an administrator. This system is actually running on a P390, so I'm using a P390 distribution. SIE1, another special user. sysa, well, that's the admin. But if you notice something there, it's this initial name. What is an initial name? Well, if you go back up here to the main menu, you'll see up here that there's this IESE ADM thing. Ignore this other word, no one knows what that means. But this right here is the panel that we're actually looking at. So if we go to resource definition, you see IESE def, go to user interface tailoring, IESE CTL. What we're going to do is we're actually going to add a panel to the system. So let's look at what that looks like. If we just hit enter, you'll see all the panels. Ah yes, there's IESE ADM, and there's all of the options that we saw a minute ago that we could select. Now what we're going to do is we're going to actually add a custom panel, but we're also going to add a custom selection panel, because all this is just CICS, so we can just execute whatever CICS transaction we want. So we're going to go to maintain application profiles. We're going to create a new one, and this is a bit of a slow machine, so it is what it is. We're going to call this one DITTO VSE. Now this is not going to make any sense at all, but it will make perfect sense after a little bit. But we need this program to be able to do literally anything on VSE. If your VSE system does not have DITTO, oh boy, you're gonna have to wait for the advanced video. Alright, so we're gonna start a transaction called DIT. Case is gonna be mixed case. There's no data, and there we go. Alright, update application profile has been added. Now we're gonna go over to selection panels, and we're gonna look for IESE prog. And we're actually going to duplicate this. So if we just do add, it'll copy it. We're going to call this panel user. We'll add a little extra space there. This one's going to be DITTO VSE that we just added. This is going to be DITTO for VSE. Alright, update. There's no help text, but that's okay. And if we go back to our application profiles, there's, well, if it would ever load, that is what we just added an entry for. So we basically copied the main menu for the programmer type user ID, and it now has our custom option which we need. So now we can actually add a user. So if we go to prog, highlight it and do add, that basically duplicates it. So we're going to add the user called user, the password's going to be pass, days, okay, so it's going to ask us to change it, revoke date, none, and this right here, panel user. This is going to be a programmer. A general user is a little bit less capable of doing stuff. VSE does not have very good security features. Okay, user ID, that's fine. Now come up here and go to 2. Now, we're gonna say yes, no to a bunch of stuff. So we want 1 for yes. So, do you want to be able to receive news? Yep. Escape to Kix? Yes. That is pushing F6 on a main menu. It allows you to enter any Kix transaction you want. That's pretty important. Does the user want a primary sublibrary? Yes, for sure. This is important. We're going to see what that means in a little bit. Can user submit? Yes, yes, yes. Can user enter all commands? No. No and no. So that's the best way to secure it. And if we go over to Kix, yeah, do not bother changing these. Do not change the resource classes. You can easily break something. And if you modify the transaction security keys and you get them all messed up, you have a locked out user ID. In this case, we're just going to leave it at class 1. And then ICCF options. And we're going to give the library 11. Again, you'll learn what all this means in a moment. Do you want to accept the remaining defaults? Sure. Alright, so now added our user. So let's back out through this extremely laggy dialog system on this extremely slow machine. And we're just going to sign out. So now we're going to log in as our user. Okay, new password, user. Alright. That is our new option. So what is DITTO? Well, it's basically a file browser for VSE, and is probably the most important program you can have on VSE system besides Kix. So what we can do is we can go into our program development library and start understanding how this system works, because there's really about 3 ways to store files. So we have our primary library here, and there should already be some files in here that I placed earlier. There are 2 files that we can use, and we're going to take a look at those in a minute. But we are currently looking in the ICCF library with the number 11. This library type is for storing source code. And if we look in library 59, which we can't, well, there's plenty of libraries that we can't, that we're not authorized to access, but you can look at other user libraries as well. Like library 9 is for the Prague user ID, it's unauthorized. We can only see 11, and this is where you change all those security key options if you're so inclined to do so. Okay, so we won't be looking there, but we can go ahead and look at the batch queues. Remember, this is a batch-oriented operating system, so everything we're doing revolves around a batch queue. And we're going to take a look at those batch queues later. Create an application job stream. This is definitely not what you want to use. This dialog sucks. Do not use it. There's a much easier way to compile a program, but menu 3 is pretty much to compile something. Okay, problem handling. This right here is for like a dump analysis. We don't really care. Operations console. I do not know why BG is paused. Let me switch over to the actual console and fix that real quick. Alright, thanks to the magic of video editing, I went ahead and just swapped that out right there. Okay, that was a paused partition. If we do DA, you'll be able to see everything that's actually running on here. And we're going to scroll back up so we can see that. So if you do a DA, oh yeah, you can see what was paused a moment ago. That was the user adding thing. You can push F7 to scroll up. These are the partitions. This is a very much so, very antique operating system. This right here, when you do DA, displays everything. Like literally pretty much everything. So this right here is the line for the printer, which is inactive. This right here is for a logical reader that we don't care about. This is partition F2, which is running Kix ICCF, also called the Kix transaction server. Partition F3 is running VTAM, which of course is one of the networking systems available on the big 3 IBM mainframe operating systems. F4 is running Kix old, F5 through FA are empty. There's the logical printer for F2, F4, and F3. This is a Z partition, which is a dynamic partition. This is running a VM pass-through gateway service, which networks to a VM CMS system. And then there's the reader. And if we scroll down one more, we can see the end of that output. We can do DQ to display the space usage, but unfortunately we can't actually do that. Also, you can tell the system is networked because this right here is the actual machine host name. If this was a non-networked machine, it would just say system VSE/ESA, but because I'm relatively unoriginal with naming things, I just called the system VSE ESA because, well, that's what it is. So that's the console. We're going to be going there pretty frequently, and we can display active users if we want, and you can see there we are logged in. Looks like we've done a lot of input and output. We can go back. We can keep going down to file management. Oh boy. Files? Okay, this is for like vSAM datasets. If we display and process files, you're going to be shown vSAM files. If catalog name didn't give it away, there you go. These are all vSAM files. Now, some of these, however, are a little bit more advanced. These three here, these libraries, are very important, and we're going to look at what libraries are in a little bit when we get to interacting with DITTO. But those libraries are basically where programs are stored. So we're looking at all the data sets that is on IJSysCT. If we put in VSE SPUC, which is the other, it's the user catalog, and we look at that, you can see there's other files on here as well. And those tend to be on a different drive. This is a 2-pack system. There's 2 disks on this particular machine. And you can see here's a few other things, like there's some Kix stuff there, some temporary files, PC host transfer file, that's for the end file function, which we're not going to cover in here. There's the control file. There's the primary library. If you recall something from a moment ago where we asked, do you want a primary library, and we say yes, we're going to take a look at this. This is where our programs get stored as this user. Text repository, that's it. Okay, and if you're so inclined, you can actually add a vSAM file using this, although you probably don't want to actually use this dialog to do it. You're probably going to want to do it using JCL. Yes, this system has JCL, and if you thought ZOS JCL was hard, boy, I ain't seen nothing yet. It only gets worse from here. Command mode. This allows you to execute all of your commands, like your traditional ICCF commands, which are probably not really useful, but for better or for worse, it exists. Try to stay out of command mode. It's a really bad way to get anything done. Kix supplied transactions, well, this is Kix. And finally, we made it to option 9, the thing we spent so much time adding that I have not explained at all. DITTO. Alright, so this is the most important program you can have on VSE. What this will allow us to do is literally look at our files. And it's pretty much a do-it-all, and this program exists on ZOS and VM as well, if you're so inclined to have it, if maybe you've used it. So we can browse data. Oh, well, this is pretty neat. You can just browse physical disk data. How about Vulsar? We're going to say DOSRes. Well, there you go. If you ever wonder what a CKD DASD drive actually looks like, with the whole variable track length and all that stuff, well, there you go. Well, it's not really variable track length, but it's variable record length. We can edit stuff, so we can edit vSAM files directly, we can edit a library member, or we can just edit a disk track. Be careful using this, you can really break your system with DITTO. But we're going to go to option 5. We're going to go to list directory. So, like, where are programs stored on VSE? Well, the answer is in a library. prd2.prod is the library on this system where this good stuff is, so the compilers and all that stuff. This right here is in a way, it's like the actual library itself. This is a sub-library, so it goes lib.sublib, and you're going to see that notation a lot and stuff when we start to actually write programs in a couple minutes here. So if we just list everything in prd2, it's going to give us a lot of output because we're actually out of memory. But if we go look in prd2.prod, it's a little bit less, and it is actually going to fit all on the screen here. Oh shoot, maybe not. I did install a few extra things on here. So here's the name, and here's the type. So this is the file name, and here's the file type. Very reminiscent of like MS-DOS or something, or Unix. Now if we scroll through here, we'll see that there's all these miscellaneous and random files that aren't really particularly useful. A, of course, is an assembler macro. C is a copybook, if I'm not mistaken. Actually, we can just tab over and do edit. Let's see what it is. Ah, we're out of memory. Well, we're going to have to shorten down our listing here. If we look at star.z, what? Okay, I don't really know what happened there. That was not supposed to happen. Okay, 5.2. There we go. Z is JCL, so if we look at literally any of these, let's just pick a random one. ADM is for GDDM. Oh, we're still out of memory. This is going to be terrible. If we look at star.phase, these are actual programs. Like, this is it. These are actual programs that we can run. Like ADM, again, there's GDDM. If we go to the bottom, you can see that there's the sort merge program. If we locate IGY, okay, well apparently it's find IGY. This is the COBOL compiler itself. For instance, IGY CRCTL is the actual COBOL compiler load phase. So when you say in your job control language that you want to execute IGY CRCTL, that invokes a COBOL compiler. So now that we've done all that, we're not going to bother with editing because our partition is short on memory, but that is okay. From here we can also print out a file if you want. Not much real reason to do that. But this is how you browse your files. So let's recap. You had the ICCF libraries, and the ICCF libraries is where your source code goes, and it's only source code, and those are addressed numerically. Nothing but ICCF can see those. You had traditional VSAM datasets. Those are stored everywhere. If we look at the VTalk or label area, if we list VTalk entries on DOSRes, you'll see, there's our VSAM files again, except there's a few other things as well. There's also traditional SAM datasets, and those look pretty much identical to ZOS datasets, if you will. But there you go. There's all the, also tells you where all the free space is. VSE is an operating system of hard knocks. You have to manually tell it where to put that file, and it will, well, older versions will happily let you overlap another file. So there's our SAM datasets and our VSAM datasets, and then we had our libraries. The libraries themselves are stored on big VSAM datasets on some volume somewhere on the system, and those are kind of like partition datasets on ZOS or folders in the Unix Windows world and DOS world. So with that, now that we've viewed the console, by the way, we're looking at Kix right now. In order to get out of this, you need to hit F3 because that was a Kix command line. If you type in DIT, it'll start DITTO, but we're not going to do that because it takes up time. So now we know how to add a user, we know how to log in, we know how to list our datasets, we know where our source code goes, which is in the ICCF library that we've assigned to ourselves, in this case 11. There's our DITTO profile. There's the editor, the ICCF editor, which we're about to get really good with. We know how to get to the console, that's just under operations and then console. And we know how to pretty much find anything as well, so we know how to find assembler macros, know how to find load programs and all that stuff. So with that, let's look at how you actually write a program and how you would run it. Okay, so there's two things here. This is the actual COBOL program. And what we're going to do is we're actually going to delete this. This is the JCL to compile it, but we're going to regenerate it. So tab back over, you can hit F2 to refresh, and we're going to compile. So again, there's the source code. If you didn't know, there are 7 spaces that lead here. So you need to go 1, 2, 3, 4, 5, 6, 7. And my space bar quit working for a moment there. And then start typing. Alright, so let's compile this. Now, this right here is basically an automatic JCL generator. You can do it by hand and you can manually type out the JCL, but it's kind of confusing and it's not really good. I think it's best to learn by example. So, source type. An online program is a Kix transaction. We're not writing a Kix transaction, we're writing a batch program that we can submit using JCL into the BG partition, which is like the special do-it-all random stuff partition. It's the catch-all one. A map definition obviously is for a Kix BMS map, and a batch subroutine is literally exactly that. So we're going to write this in COBOL VSE. Now your system may have different entries here. Mine has high-level assembler, PL1, COBOL, C, report program generator 2, and Fortran. Do note that if you are unfortunate enough to have to use RPG on VSE, it is completely different from RPG like ILE RPG on AS400s. DB2 connection, no. SQL is basically what this is. Some will say SQL Server instead of DB2 Server if you're running an older version of VSE, because it was called SQL Data System for VSE, and then it got renamed to DB2 Server for VSE, so there you go. That's just a SQL system, we don't need that. Catalog, yes. We do want to catalog it. What that means is store it into the library, and we're going to tell it what library to use in a minute. So, do you want to catalog? Absolutely. Name of the job to generate. I always say C for compile, and then the program's name, so cop test. Now we need to store this in an output member because we cannot just submit it immediately, because our template is user generic. It's going to store it into a library, or it's going to try to store it into a library that doesn't exist. So we're going to need to save it so we can edit it. Oops, wrong key. Need to push F2 to refresh. And there we go. So we're going to edit this. Oh boy. Welcome to VSE, the hardest OS. This is why. Okay, let's walk through this. This is a very complex example, and if you understand this, you will literally understand anything. This right here is the primary job card. Note that it starts with star, dollar, dollar, and then there you go. This is job execution control language, if you will. This tells the scheduler, which on VSE is called power, which is a backronym for priority output writers, executors, readers, I don't know, something ridiculous. This right here just pretty much tells the system what the job name actually is. If you just submit a job with this as the first card, it's gonna crap out on you. It's gonna say, ooh, where's the job name? So you gotta have this. This right here tells it what to do with the output. Also note here, I kind of went premature there. There's a job name. This is going to be disposition D, which means run it, store the output in the output queue. This is running a job class A. A tells it to run in a BG partition. If you run it on job class 0, it'll also run in a BG partition. If you want this to run on some other job class, go back to your console, do DA, and it will tell you what the associated job class is for the partitions, which you may need if you're running out of memory or something, or as they call it in IBM world, storage, because calling it memory implies computers can forget things. Alright, so what do you want to do with the output? Well, disposition D is going to go into class Q, which means store in the queue, as in QUEUE, with priority 3, which doesn't really matter because it's the only thing on the system at the moment. So job, and then everything after that is just description. Okay, now we're getting into it. What we got to do is we got to build up to where we execute the COBOL compiler here. Now, because this was machine generated, basically macro templated, it's going to have things that look like it was made with a macro processor, because it was. Remember we said 1 to cataloging, so this is what this says. This is a variable. And this line before it says we want to search in all the libraries listed here, prd2.scee base and prd2.prod. We're looking for all file types. So phases, assembler macros, copybooks, everything. We're looking for everything in these two libraries here. And you can have as many as you want. We do want a catalog, and if this is set to 1, then go to cat. Okay, let's go to cat. Okay, so here we're at cat. So libdef phase. Star is for reading. Being more specific is for writing. So we want libdef phase, so where are we putting phase, or where are we going to put our phase that we compile. We want to catalog that into primary.prog. This is the sublibrary. Actually, we're going to say primary.user because that's our username. There's the library, there's the sublibrary. When you said yes to that one option on the user account creation dialog where do you want this user to have a primary library, this is what it means. And then we're just going to keep on flowing through here. So we're going to specify some options to ultimately what is the linker. So this is where it gets kind of confusing, but this option thing just sets the magical options variable, and both of these are options for the link editor. So we want to see if are there any errors with the linking. Of course, we want a symbol cross-reference, we want a symbol listening. We do not want an object deck punched because that's just a waste of spool space, and we want to catalog it. And then just like on the MVS linker, well, kind of, because it's derived from this back in the 1960s, we're saving it as the phase called cobtest. We're storing it, you guessed it, wherever it'll fit, which is, in this case, libdef phase. Let's say if you said no to cataloging, well, in that case, we go right here, because if this is equal, then here, but if it's not equal, go to the next line. So, if we said no to cataloging, it's going to tell the link editor to not catalog it, but it is going to list out pretty much the entire object file, and then go to ncat. Okay, boom, so now we're here. But if we said 1 to cataloging, we're going to go to this label here, say that we do want to store the phase, and we do want to catalog it in primary.user. We want these options to go to link editor. We want it to know that it wants to store it as the phase called cobtest, and then we're done. Now we can actually execute the COBOL compiler. All that was just getting set up. So again, up here, this tells power, or really in this case the VSE scheduler, where to actually find the COBOL compiler, which it is in this case it's going to be in prd2.prod. Now we're going to execute it. So we're going to execute IGY crctl, which is the COBOL compiler. I don't know where in the world they got that name from. And then there you go. This first option here, or this first line here, is the options that go into the compiler. Because really, everything from here to here is literally like the input into the compiler. Which, in this case, we gotta get a little clever. Because how do we get our source code into the compiler? Well, we're about to see in like a couple seconds here. So we want to compile COBOL with all these options. Okay, great. This right here is a macro that when Power sees this, it's going to basically substitute and slipstream in our COBOL source code. Because again, all these star $$ options, these are picked up by Power, and they mean something special to it, but not really the VSE scheduler. So, alright, great. So we're going to do a source library inclusion. The ICCF file is called cobtest, and it's in lib11. If you note, we are currently looking at files in library 11, and we do have a member called cobtest. This is the source code. And this right here is basically the control D end of file, whatever you want to call it. It's the end of input to the COBOL compiler. Now, if catalog is not equal to 1, or the maximum return code from the compiler is greater than 4, meaning we got an error, then we're going to skip the link editing step because it's just going to waste processor time otherwise because the link editor is going to fail. Assuming that we do want to catalog and the return code is not greater than 4, then we can execute the link editor, which is going to have a fixed size of 256K. And if we did get an error, we're going to skip over the link editor step and go here. And then this right here is the end of job signal, and then this is the actual tell Power that we're done. If we go up a little bit, you'll be able to see all that. Okay, so we made our edits. Now we're going to actually submit it to the queue. So what we do is we push 7 to submit. So we're submitting. Supposedly. Okay, it's submitted. Now we're going to go back. We're going to go back to operations and console. If we scroll up, we'll be able to see the output. So there we go. So again, we submitted in class A. So this is where it went. So the BG partition is job class A. So, yeah, job. Cob test, compile program, cob test. Date is today. Okay, boom, it ended. Max return code was 2. Well, again, that's less than 4, so that means everything worked well. So we're done with the console. And we're going to go and we're going to check the output from that. Now, if you're in the ICCF menu, or the file listing menu, you can just push F12, but F12 is a dead key here, so we're going to go to operations. Oops, my fingers are still hard-coded to a different user ID. And we're going to look at manage batch queues, which is there. It's on the main menu. We're going to look in the list queue, and we're going to go to the latest occurrence of this job. As you can see, I've submitted quite a few jobs called this before. We're going to display. And this right here is taken today. You can do F10 and F11 to scroll left and right, by the way, because this is a 132 column printout for like an old style line printer. Our terminal's only 80 columns wide. Alright, so same thing that we're getting before, and this is where we actually execute the COBOL compiler. You'll notice that it just sort of echoes the JCL as it gets it. It's pretty primitive, but now we're executing the COBOL compiler, and here's the output from it. So this is COBOL for VSE ESA 1.1.1. There's our option parameters for the option thing, which again, it's going to pass these off to something. And then, there we go. And we're going to keep on going. Options in effect, yeah. There's our source code listing. Keep on going. And, okay, then now we're looking at the link editor. Again, these options are going to be sort of propagated through the program, and I'm going to go give a little bit more information on that option parameter in a second and how that really works, but it's sort of like a cascade, if you will. As you note up here, it's going to say, oh, the options are there. Great, it got locked up for a second there. There's the JCL options, and then here's the first line of input. And then we go down to link editor, it's like, hey, here's some other options that is consisting of just this. But really, it's a little bit more confusing now. We're going to take a look at that. Don't worry. There's link editor, yeah, unresolved references, don't worry about it. It actually ends up producing the program just fine. And we're gonna go take another look. Oops. Oh. I backed out of that accidentally. Alright, let's take another look at that option. Come on. I know this thing's old and slow. Again, the first option goes into the COBOL compiler. The second option goes into the link editor. Technically speaking, at any given point, it just sort of starts chopping them off. So if you run multiple programs that have multiple means to accept this option parameter, it's just going to stack them off the list, like boom, 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 boom. And technically speaking, the link editor can still read these, but it's like, hey, this ain't for me. This is for me. Extremely confusing, and it's a mess to understand. Okay, great. We have our program. It's there. Let's go look at it. I'm going to go back into Ditto. We're going to go option 5 and then option 2. And we're looking in primary.user. Haha. There it is. This is our program. If we edit it, it looks like a program. Oh, and you may actually be relatively surprised with just how primitive, but also how advanced this operating system truly is. I mean, this had runtime error checking, and this might as well have been the 80s. I mean, you overflowed a number, boom, you had your saving grace right there. And so, keep that in mind as we see this being rediscovered in the modern world. VSE had it first. Now let's actually run our program. And this is going to involve like some fully custom JCL. So we're going to go back into our program development library, and we're going to add a member, which you can do by pushing F6. We're going to run cob test. Alright, so the quickest thing to do is just type in, and we're going to get to it. Turn on caps lock, because you always type in caps lock. Star, $, job. Okay, it's kind of hard to type because this microphone's in the way, I apologize. Job name is run cob test. Okay, so there's our job name, there's our job class, there's our job disposition. We're going to list it to printer FEE. This is hexadecimal, this isn't a fee, you don't have to pay. That's just what it is, and it's a logical device that exists in every partition that will redirect the output to something. In this case, class A is sort of like, not necessarily A for automatic, but for list queue, it kind of is. If you submit this job into an actual punch card reader, class A is going to go out to the printer. If you submit this from the ICCF virtual reader, which is what we're doing, class A goes to the spool. Alright, so now we need to do our libdef thing. Actually, we're going to do this the safe way. Okay, so what was so safe about that? Well, we're looking for everything in the libraries prd2.sce base and primary.user. This is where the phase of the program is actually stored, but this is a safe bet to do with other languages as well, especially if they're dynamically linked. Yes, VSE has a dynamic linker, and it absolutely does work, and this was in basically the 1970s. In this case, dynamic linking is achieved by having other phases in another library, so if there's phases that show up in prd2.sce base, there you go. You can combine them with the symbols that you need out of your program. There they are. So we're going to execute our program. There's no input, into job, bam. Alright. Now we're going to submit. We're going to go to our list queue, and we're going to run cob test. Oh boy, that was easy. That's it. That's literally all you do. It's actually deceptively easy to use once you get the hang of it. And in fact, that's all. That's how you run a program. That's it. That's pretty much what you do. And of course, F12 goes to the list queue. You can also get that from the main menu, which, because this is a programmer user ID, is manage batch queues. It's right there. There's the exact same output. If this, there we go. That's how you use it. Now, I mentioned that this is in fact a networked system, and this is. We're going to demonstrate that later, but like all good users, we're always going to free up the spool space. And yeah, you don't want to fill up the spool, because if you fill up the spool in a VSE system, it becomes kind of impossible to get anything done. And then we're done, so now we can just log out. But there's a few other things that we can look at before we do that. If we go to operations and then display system activity, you'll get this great... Okay, it's not that great, it's a little bit ugly, but it's about it's the best you're going to get for system activity display on VSE. Here's the scheduler priority for the batch partitions. Of course, Z, Y, and P and C, those are all dynamic partitions, and then B, G, and then FA through F1. Actually, I guess it includes FB, because they're in hex. Those are the fixed partitions. And you can see that there's power running, and the actual phase is called IPW power. There's VTAM, and the phase name is IST, INC, VT. That is, of course, IST and IPW. If you're unfamiliar with IBM, at least in the mainframe world, everything they make is prefixed with 3 letters. IPW is for power, IST is for VTAM, so the phase that's running for VTAM is IST invoke VTAM, INC, VT. For the security server, well, BST is the perimeter name there, or the program prefix name. Kix is obviously DFH. There you go. You can look at the dynamic partitions as well, and you can see that there is in fact one active dynamic partition, which is running our PVMG job there, which ties it off to the network. This machine has multiple networking protocols running on it. It does not have TCP/IP though. Oh yeah, transfer files and jobs to another system. There you go. That will submit a job to another system, which is not doable because they lie. PNT $node, forget it. You're never going to find that file. And there's no documentation on how to make it either. You just kind of have to know. Retrieve news. You can do whatever you want. You get a job message every time a job runs, which is useful, I guess. Personal computer move utilities. This is end file. Oh. Yeah, this is literally end file. That's IND $file. That's the file transfer dialog, where you can transfer files through your terminal. Imagine basically Kermit, but for IBM mainframes, or Z modem, or Y modem, or any of those old BBS file transfer protocols. PC file transfer, there you go. Now you just do the end file right away, and it will dump it into a host transfer file, and from there you can move files out of the host transfer file into a VSAM dataset or an ICCF library file. Note that VSE libraries, like where programs get stored, is not in there. And that's basically it. I mean, VSE it's pretty confusing at first, but that's pretty much everything you need to know. It's not too hard to do. It's not the worst thing in the world. There is definitely worse out there. And that's it. Good luck.